Okay. Um, how would students respond? Ba, 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 da, ba. They push play. The soldier gets shot out of the cannon. Was that a cannon or a volcano? Yeah, the cannon. The cannon quickly and then descends. Descends slowly after his parachute gets deployed. I feel like okay, well the students aren't gonna have the same vocab, but they'll say the soldier. I knew there was an S. The soldier gets shot out and then comes back slowly because of the parachute. They might not talk about him coming down slowly. No, that was a lot cleaner. Rachel's was a lot cleaner. Oh well. Whoa. Wait, do I have to sketch the original? Do I have to sketch what the video did? Oh shoot. Ah. Well, kid's definitely gonna try to push play before sketching it. Probably goes up quickly and then comes down slowly. My laptop's gonna die. Oop. Yikes. Wait, which one's mine again? What happens if you cut off a bit? Does he just vanish? He does. Ah, okay. So my guy's a solid guy. Want to see someone teleport? Ah, shit. Okay. Don't get distracted. Don't get distracted. Don't get distracted. Okay. Yeah. Kids are probably gonna. Smarter kids are probably gonna just do. I shouldn't say smarter kids. That's. Oh, that's on record. That's fine. Something like that. Oh yeah, kids are definitely gonna be distracted by this. Oh, the trackpad failed. Okay, so that's another thing. Trackpads. I'll probably have mice. Oop. Okay, now it went a bit higher than it should have. C'est la vie. Well, how to do a graph of the person's height versus time. What does this graph say will happen to the person? The person will shoot up at a constant rate. This is likely what? What grade are these kids in? Constant rate. Then fall at a lower constant rate. Prove this graph by, well, I can't play this, but I think by simulating, children are not going to say that, but simulating the acceleration and deceleration of the soldier. Well, how to do a graph of the person's height versus time. What does this graph say about what will happen to the person? Yep. You should help them fix it. Use this sketch tool to help you show your work. What else? Why would a kid say this is bad? They'll be like, oh, it's not pointy. That would mean he... What, flips upside down? What would a kid... actually say? A kid would say... smooth out what happens when he falls, when he hits the top. Watch this video. Oh my gosh, it's still recording. There's no way this file didn't get corrupted. So I'm sorry if there's any empty space in this. My laptop died and I put it in charge. Okay, what kind of something to be interesting? I don't know. Left and horizontal displacement. But that's not what kids are gonna say. Kids are gonna say the speed of the car. Maybe the acceleration. Do I know how to type? No. Corners might be interesting to look at on the graph. The distance between green car and the nearest blue car. Nope, distance traveled. Well, wouldn't that just be... What time does it do its thing? Let's just say it's gonna be... Where is it? Oh. Am I cheating? Maybe. Boom. But at what point does that happen? Nope. There's a straight line. I'm such a smarty. Boom. Boom. Hit it. Nope, too fast. That's kind of neat. Okay, wait. We can fix this. Because it's 1 Mississippi, 2 Mississippi, 3 Mississippi, Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi. Right there. Right there. Right there. Boom. Check this out. Well, check it out once it resets. Boom. That's right. I called it. I knew it would be linear. That's kind of messing with my eyes. Okay. How would you have to fix it? It happened to mine too. That's a good thing. Where'd my car go? You're perfect, Tamika. Don't touch anything. Because it overlaid with the demo car. You can fix it by not touching a thing because it's perfect. How would a kid react? I don't know how a kid would react. I mean, she got lucky to not do it intentionally. Let's see. I'm a kid. I do it. My car doesn't show up. I feel like the first thing that a kid would do would be like redraw it. My thing disappeared. Well, I would ask her, why do you think it disappeared? Where do you think it could have gone? She's like, I don't know. Well, I'd be like, okay, try redrawing it a different way and see if it works then. That's all I got. To watch the animation request. That's all I got. Or was that what you meant? That her car disappeared? Oh. See, this is awkward. Did my car disappear? Ah. See, now I feel silly. Boop. Boop. That's what you meant. Totally did not interpret that. See, now I feel silly for not understanding this. Well, too late. I shared it with the class. But only you'll know, Dr. Lovett. Let's people the overlap part. Vanished at t equals 7 because according to the graph there is no points or car past that time. See, I didn't even understand the question. Okay, well, it's not perfect. She can fix it by keeping car place. We're continuing with the constant function where the car left off. Oh yeah, kid will definitely say it goes up and down at a constant rate. Oh wait, no, that's what I think. Well, I know it's sinusoidal. It follows a negative sinusoidal graph. What a kid would say. It goes down, then goes up. Cyclically. I'm pretty sure they would know that. Cyclically. In a cycle, in cycles. Dang it, Rachel. I'm gonna leave it like that. You got me beat, Rachel. Green card starts at midline and decreases until it reaches the minimum and then increases. Which is the midline. It's the maximum that it reaches. Yeah. That's on me. I can imagine, because I did this, I'm pretty sure. I can imagine just going boop. And then probably boop. And then probably boop. And then boop. Oh wait, I should connect them. What happens? Does it glitch there? What happens when I do that? Let's see what that does. Well, that was disgusting. How long is the period? One Mississippi, 2 Mississippi, 3 Mississippi. Okay, cool, got it. Every second is one phase change. So we start here. Boom. You wind up here. Boom. Stay in place. Boom. Come back to the midline. Boom. Boom. I can't really tell heights what happens anymore. Boom. I guess I shouldn't make a straight line. So I guess I should. Whoop. Whoops. What happens if I do that? Spazzing out. Can eyeball this. Well, what is happening? Can a man have some grid lines? You know what? What if I push play and then... Nah. You know what? It's not gonna be perfect. Their kids are gonna want it to be perfect. Okay, wait, so it's there, 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 there. Okay. How is it? Why am I struggling? How is it already 22 minutes? I don't know. I'm sorry, Dr. Lovett. Okay, 2 seconds. It's there. Read it a little bit before 2 seconds. Let's play sinusoidal John Lennon. Let's see. Is that what I'm thinking? Yep. We're gonna go off of that then. That's a smarter thing to do. Right there. Minimum is right here. Around halfway. Doing this up here. Halfway. Let's put this magic to use. No, wait, it's a whole cycle. Why does everything hurt? Okay. Halfway point, boom. 4, 5. Boom. 1, 2, 3. Boom. So it should be And that's it. Shoddy work. You know, it gets the job done. We're gonna go with that. Oh. Oh no. It looks like it's split into two possible realities at once. And then collided back into itself. What do I think happened? I think the program broke. If I were a machine interpreting this, I would assume the green cart split into 2 dimensions and traversed 2 possible paths before colliding into itself and disappearing. And since the time here is there's a gap here, that would mean the card randomly appeared split into 2 dimensions, traverse 2 possible paths, colliding with itself and disappearing. Do we get to see it? Rude. Not on my watch. We're gonna do this. Hey, look at that. And then they're gonna annihilate themselves. Boop. It's like quantum physics. That's kind of neat. It goes back in time. That's what this one's doing. That's from a past. That's from a future self. Oh no. Okay. Student thinking. They will think it's a circle. They need to be able to see this. They can't just. Can they visualize it? Would they reason it out like this? Maybe. The reason that it's 2 heights, 2 different cards are needed. Students aren't gonna get this. Not to be deficit, but some students will take a minute for them to understand. This is a height graph. It shows the height of the card. It doesn't show the path of it over time. We'll go with that. On a blank piece of paper, draw your own graph. I'm so sorry. I drew a logistic function. Logistical. Was it logistical growth? Yeah, I drew a logistic function. Showed how deer were born. Ooh, human life. No, yeah. Deer were born in the woods. Deer came into the woods. And quickly proliferated. Did before leveling off. Can I actually draw one? Oh, shoot. Can we just say I did? If I lose point, oh, it's a bonus challenge. So, boom. See, now I feel like I need to. Mother and father deer found themselves a small herd of deer. I guess you can't really have population growth. A small herd of deer found themselves in the woods. They quickly started populating. For a while, the amount of deers was growing rapidly. But soon, wolves realized that there was plenty to eat in the woods. So, they entered the forest. For some reason, the deer population leveled off. I don't know how it's leveled. For a while, no. That's fine. I'm done.